We are very happy to have you here, very excited for this evening. But before we start, we would like to introduce Raiden. He's the host tonight. Raiden?
Hello, everyone. Welcome to Ginetta. So I've already seen a few familiar faces, but I'm curious. How many people here have been to Ginetta before? That's like half the room. Awesome. We really like our space here, and the space becomes even better when we have smart, curious people come here, hang out with us, and talk to us. So thank you so much for coming. As for who I am, my name is Graydon. I am originally Canadian, but before you come and ask me, I'll stop you. We're not going to become the 51st state. It's so funny. Nobody knew anything about Canada until like 2 months ago, and now people want to talk about Canada. Anyways, at Ginetta, we are a human-centered digital innovation agency. We've been here for 15 years, and you may not know us, but you've probably come across a few of the things we've designed, that we've created. And a really common theme at Ginetta, and one of the biggest things we were built on is this idea of being human-centered. When our business first started, a huge amount of the applications being built in Switzerland and even across Europe were really being built out of function, out of we need this application to do this. But what Ginetta really tried to do and tried to really challenge our customers with is actually understanding not what the features are the customers need, but actually understand the customer's workflow, talk to your customer, understand their behavior, understand how you can make their lives easier and more enjoyable. And as an example, so we're doing a lot of work right now with Groupe Mutuelle. They realized that they needed to revamp every one of their digital properties. But to do this, we told them from the very start, if you really want to understand how to give your users a better customer experience, you need to talk to the users. You need to talk to the people at your call centers. So before we even started, the first thing we did was talk to the users, talk to their customers, and really understand their pain points, their workflows. On our website, and actually if you look behind there, you see big writing that says, "We simplify." It's something that's really important to us. It's not about creating the most flashy experience that draws the eye. It's really about, often where we come in, is simplifying things that are quite complex. Does anybody here have Twint on their phone? Yeah, it's one of the things that it's amazing to me coming from Canada, where there's not many countries that have apps that are really proprietary to their country that absolutely everybody has on their phone, which for here is SBB and Twint, and maybe Mateo Swiss as well. So I think that's pretty wild. But with Twint, when Twint came to us, they had a huge amount of hype behind them. There was tons of momentum. They had the big banks behind them, and there was a huge need for peer-to-peer payments. The problem was, when they launched, nobody was downloading their app. So what they did is they invested millions into huge advertising campaigns, including billboards all over Switzerland. So that worked. Everybody was downloading their app. The problem was, when people were downloading it, they had no idea what to do with it. It was quite confusing. So where we came in was to completely revolutionize and rethink the way that humans should interact with Twint. And so what you see on the phone all comes from the concepts that we created for them, I think, 7 years ago now, maybe 6 years ago. And another huge thing that we're starting to do more and more here at Ginetta is to not just create digital experiences, because if anybody here works at a company of probably more than 500 people, you have multiple different digital experiences and many different digital touch points, whether they're meant for internal within your business or for your customers. But what we're starting to do more and more now is help companies that have a large digital ecosystem harmonize them, so that there is a consistent touch point, or you have a consistent brand feel across every touch point to make it way easier to create new digital products. So when we redesigned Roche's global website, not only did we redesign the website, but we also created a global design system. that is used for every single digital property to help maintain brand consistency and make it way easier for the teams to create new digital experiences. Anyways, that's a little bit about what Ginetta does. Thank you so much for seeing us. Keep coming to see us. We love having all these people here. We love the energy, and hope you all have a great event.
So tonight we are here with all of you to talk about AI agents. We are seeing many people that we know, but we are seeing very many new faces tonight. Before we start, we do some housekeepings. For the faces who don't know us yet, we are the organizers.
Yeah. Alain, here I'm a designer, working with a lot of tech companies on digital products.
And I'm the techie, as you see, the typical techie. So we're actually proud to announce that we're 20 years old, him and me, together, both. And we're doing Digital Shift also since, I think, 10 years. So this year is very important for us.
Yeah.
Thank you. And tonight is also special because Walt, who's my business partner, he will be moderating tonight. So if you've got any questions about AI, ask the speakers, ask Walt. And if it's more technical, ask me. So why are we doing Digital Shift? As you might have seen, we look like the typical Swiss, him and me, right? We do Digital Shift because we are working in tech, and in tech, it feels like all 3 months there's something new and shiny and beautiful. And if you're like me, then it's everything new is cool and I want to have it. But most of the time it's not like that. So we like to investigate what the trends are that have staying power. Are they real or are they hype? And if we learn something, we want to give back to our community, to you who've welcomed us, typical Swiss. We're very happy to be here because Ginetta is the host and sponsoring tonight our apéro and Greenleaf. And tonight it's about AI agents. I'm sure you've heard from Microsoft, OpenAI, Perplexity, Anthropic, Google, and so on, that they have all their own agentic systems. Why? I hope Victor and Dorian will enlighten us tonight and give us real substance. And Walter will help us keep track of everything. So Victor will be doing the first speech tonight, followed by Dorian. And then we will have a discussion, so don't feel shy to ask your questions. We have got really great speakers tonight who know a lot. And then, if you're hungry, we've still got the apéro, sponsored by Ginetta. This is for you.
Yeah. And if you like it and you want to participate again in the events, we have a newsletter, there's a Telegram, and there's a WhatsApp channel. So you can just take the ones you like. So.
Thank you. Let's start the evening.
Thanks. Good evening. And just to repeat, as you have seen, we have 2 speeches tonight, and we will have the questions after the second speech. If there is a very, very important one, we can ask it also after the first one, of course. But then we will have a little panel up here, and then we have time to discuss all the questions. So let me introduce Victor. Victor is a passionate about data science and software engineering. He's enjoying all the innovative and very changing markets and all the changes in AI. And he's a real expert in monitoring and consulting people how to use it, and you know, so many questions you can ask him and he will possibly have all the answers. So let me introduce very warm Victor. Thank you.
Very well. So as I said, hi everyone. So I'm very excited because I'm going to take you on a journey where we're going to unveil AI agents, and I'm going to explain to you how they work, what they are, and what makes them so unique. So before I start, I'm going to quickly introduce myself. So my name is Victor. I'm an AI engineer at IMTF, and I'm building RegTech solutions, and more specifically, I'm building AI agents for anti-money laundering and for fraud detection. So on the agenda, we're going to start with a quick introduction so that I can set the stage, and then we're going to look at the evolution from generative AI, going from the model all the way to agents, and if we have time, we'll have a few questions. So the thing is that AI agent can become quite complex, so the best way to actually look at it is to really break it down into the smallest components, and then to see how we actually build all the way from the smallest one, which are the models, then how we extend their capabilities with applications, and then how we transform this application into fully autonomous agents. So we're going to start with the models, which are like the engine of our intelligent system. And here we have a very simple diagram to explain how they work. So what we see here is that basically a model is very simple. So it takes an input, a single input, and then it gives a single output. The input is usually what we call the prompt, and depending on the model that we have, it can be text, it can be image, it can be anything. But it's one type of data, one single output. It has no autonomy. It will only work if you trigger it, and it doesn't remember anything. So every question is a new thing. The most famous one is, of course, the large language model. We all know OpenAI GPT-4, for example. So we say language model because this one is specialized into text-to-text, so you take human language and transform it. But you have much more. You have, for example, Mistral, Llama, DeepSeek. And also, when we talk about AI agent, it's also important to know that we have different sizes. So the large language model are the most popular one, but you also have like small language models. And small language models are not so smart as the large ones, but they're very efficient, very fast, and they cost also a lot. So when you build AI agents, it's very practical to be able to choose the size that you want. We also have different modalities. So when we talk about modality, we talk about the type of input, the type of output that you have. And as you see, there's not just one AI model. We actually have a whole catalog of models. They all have different types of inputs, of outputs. And when you're going to build your agent, you really have to think, okay, what is the purpose of what I'm building, and what are the different models I'm going to use? Because usually you don't use one model. You're going to very often combine their capabilities to be able to do much more interesting things. And then when we have our engine, now we can actually start to build real products with it. And that's when we're going to look at applications, so how we actually extend their capabilities. So if we look at this diagram, we compare it to before, what we see is that now, instead of exposing the model directly to the end user, what we're actually going to do is we're going to wrap it into some software application. Here I use Python, but it could be any language. But now it's extending it because, first of all, the input is not just a single output. Now you have an application, so you can get multiple type of information. And then the software that you're going to write is actually going to take this information, those inputs, format it to a prompt, give it to the model, and then take the output and format it to get better output. And usually when we build AI applications, we have, for example, those two things that are very practical. So the first one is prompt engineering. So to explain it simply, prompt engineering is kind of like software engineering. The only difference is that instead of using a programming language, we're going to use human language. And we're going to write prompts instead of code. And this is what we're going to use to communicate with our AI model. And we have different techniques of prompting. There are too many, so I'm going to give you two examples. But the first one is, for example, few-shot prompting. And few-shot prompting is as simple as basically giving examples to your AI model so that it really gives you the output that you're expecting from him. And then the second thing that's also very widely used is chain of thought. And the chain of thought is that you're going to ask the AI model to think step by step so that you get better precision because it's going to take more time to actually think about the output that you want. And just to give you an illustration, if you heard about O3 or you heard about DeepSeek R1 and R2, that's where it comes from. And then we also have something that's also very used, which is retrieval augmented generation, that usually people call RAG. And the idea of retrieval augmented generation, it's in the name, is that you're actually going to retrieve additional information that your model doesn't have, and then you're going to inject it into the prompt as a context. And exactly like models, you have a whole catalog of different RAG, so there's not one way to do a RAG because you can retrieve information from different sources. And just to give you a few examples, the most popular one is the basic RAG. So when we say basic RAG, we usually talk about taking documents, injecting it into a vector database, and then retrieving only the important information depending on the question. But then we have other types, for example, the web search rag. So every time you're using your chat application, you can use ChatGPT, Perplexity. They usually go online and get some extra information that they're injecting into the prompt. And then you have more complex ones who are, for example, knowledge graphs. And knowledge graph is the idea of creating a graph of information because it's a very efficient way of actually extracting relation information. But at the end of the day, as I said, it's always the same thing. You get a question, you see what information your model doesn't have, you extract it, you inject it, and you get a better response thanks to this. And now, before we go directly to agent, we're going to actually take an example, and we're going to take the example of an AI chat. So the AI chat actually went through a whole evolution, and the very first AI chat was a simple AI application, but we're going to see that actually started to have what we call agentic behavior. And so for this illustration, I gave the example of a kind of like a self-driving car. This is like what we went to. So in the very first iteration of the AI chat, this is like the most basic that you can have. We again have an AI application, so this is very similar to what we had before. The only difference is that now we have like this chat history. Because the idea is that now that we have software, we can actually use the software to remember about the previous questions. And every time the user asks a new question, we're sending on top of the question in the prompt also the whole history that we had before. And then we get an answer. And then when we go to the agentic chat, this is when instead of just remembering the chat, we also adding new capability to our chat. And if we take the example of ChatGPT, the first version, as I said, was just asking a question, you get an answer. But now you can actually do much more than just asking him simple human language question. The input is still a user question, but what the chat is going to do now is also going to think, how can I better respond to the user prompt? Because, for example, the user can ask to write you a poem. In this case, it's very simple. It's just going to give you some text. But maybe the user is going to ask you to generate an image. And in the case that he asks you to generate an image, the chat actually has to think and has to take the decision that he's not going to use the normal LLM, but he's going to use another model to actually generate an image out of it. So this is also one example of the fact that he can decide on himself to use different models. And then if we go back to the RAG, if in the question the chat realizes that the model doesn't have the information, he can also make the decision to then use one type of RAG, for example, web search, to go on internet and get some additional question. And this is what makes it agentic, this idea that he can actually think by himself and make decision on his own to give better output depending on what the user asks. And so now we can now go to the agents. So why agents so special? Because as we illustrate here, the difference between before we were making an application, a product for a user that the user is going to use himself. But actually, when we start thinking about agents, we want to even go further in the idea that we go even to the point that the agent doesn't really need a human to actually work. That's like the end goal. And so if we take like a few points, one of the things that characterize an AI agent is that he's goal-oriented. And because he's goal-oriented, he's going to be able to get inputs that are not per se by humans. It can be, for example, listening to some notification, to some emails, to some sensors. And then he's going to take those inputs and he's going to use his goal that he has in his memory to think, okay, how am I going to achieve what I have to do? And then he's going to be able to autonomously decide on the next step and on the task that he wants to do. And he can also become adaptive because you can make your agent in a way that he's able to change himself over time. And to do this, he will, like for a application, he's going to have access to tools. So he's going to be able to persist things. He's going to be able to have memory to remember. And he's going to have access to RAG and plenty of other things. And for the output and inputs, now we're really talking about dynamic inputs and outputs, not just a person who's asking something. So as I said before, AI agent is a bit more complicated to materialize. So we're going to zoom in after into the different blocks. But here I illustrate this by using what we call the REACT framework. So the REACT framework is the contraction of reasoning and acting. And in this example, we see that the agent can have multiple types of input. So I put it notification, email, sensors, and he can also have different types of output. He's not limited. And the best way that I'm going to illustrate this is I'm going to take a real-life example, and then this real-life example, I'm going to go on each of the 3 blocks, the reason block, action block, and response block, and I'm going to explain that the real life of the agent I'm going to use actually went there. And so the agent I want to take as an example is an agent that is called Luna. And the Luna agent is an agent that was built by the Virtual Protocol, which is a blockchain project. And the purpose of this Luna, and so the purpose of this agent was to do digital marketing. So its goal was very simple, is become as popular as you can so that you can have the biggest outreach when you have to promote the company. And so what happened is that there was this podcast, which is called the Bankless Podcast. And in the Bankless Podcast, in one of their episodes, they actually mentioned the Luna and they talked about Luna. And then they tweeted about this. And what happened is that Luna had as input saw the tweet that was made by the Bankless team. And then it decided to actually tip the Bankless team the equivalent of $500 in crypto because it was blockchain related. And so now we're going to see how it actually did this. So first step, there's the reasoning step. So in the case of Luna, Luna probably received the tweet as input. He saw, okay, there's a tweet that mentioned me made by this Bankless team. So first thing they did is he asked itself the question, how can I reach my goal? And the goal was become as popular as possible, so try to create attraction. So when he sent the tweet made by Bankless, there was probably some plan that was created by an LLM saying, okay, the best way that you're going to create engagement is you're going to tip those guys. That way you're going to get their attention. And you're going to retweet something to tell them, hey, thank you for mentioning me. Here's a tip. So that's the plan that he made. Once the plan was made, you go to the second step, which is choosing the tool. Because as I said, an agent has access to a tool to actually do more than just generating some text. And again, in the case of Luna, if the plan is tipping those people plus making a tweet, it means that the tool is going to need is probably access to a blockchain to make a blockchain transaction, access to another AI to write a tweet, and then access to web APIs to be able to post the tweet. And that's when we get then to the second block, which is the action block. So because before we know that he needs this tree tool, now the software can do its job. So first making transaction, getting the transaction hash, generating a tweet, calling the APIs, posting the tweet on X. And once he was able to do all this action, we can go to the third, which is basically the response. And here, the first thing that the agent is going to think is, do I have everything? So did I achieve my goal? And now we can make the decision to either say, yes, I achieved my goal, and then it could, for example, just put something in a database to say, okay, I did my action and I'm happy with what I did. Or it can also loop on itself, meaning that it can say, no, I didn't fully achieve, so now I'm going to go back to the reasoning, and then I'm going to loop until I decided that I finalized my action. And so what happened at the end of the day? Luna tipped those guys $500 in crypto, and in the next episode, the Bankless podcast again talked about 15 minutes about Luna and how amazing it is to have financial action with blockchain. So that was it. I hope that now you have a better understanding about AI agents. And if you have questions or if you want for later, feel free.
Okay. Thank you, Victor. And I guess we're going to do the questions later. So let's get to Dorian. Now, let me introduce Dorian. He's the co-founder and CEO of Squirrel AG here in Zurich. And Dorian is an entrepreneur from the first hour when we talk about AI. He is long time in the business and has a lot of experience, a lot of different companies he was involved. And so he's one of the Swiss dinosaurs of AI, so to say. And he is running a very interesting platform with his company for customers with a generative AI solution so that the aim is to make better business decisions. So let me introduce Dorian.
Thank you for the kind words to introduce me as a dinosaur. have gray hair like him, so we're probably both dinosaurs. Okay, jokes aside, let's talk about what AI agents do in real life. I have the privilege today to walk you through a couple of slides about what happens now. And I meet here another dinosaur, Jörg, right? Together we did, what was that, 30 years ago? Literally 30 years ago. Sadly, so we did Namix together, right? Namix, some of you guys know, was Ginetta before Ginetta came into existence. Ginetta is simply the Fibonacci sequence of Namix. And I remember one of the things we did together, we went to build the first UBS website at the time. That was even before Namix formally came into existence. We did that at the Institute of Information Systems in St. Gallen. And you know what we did? We went to the, at the time, top management with my supervisor of the PhD, a gentleman by the name of Beat Schmid. We lovingly called him Dr. Beat. And we went to, at the time, top management of UBS and presented them the first web page. You know what the reaction of these dudes was? We don't need a website. Money is trust. People come into our branches. That's 30 years ago, my friends. And 30 years is not a long time. We had one more thing. Dr. Beat had this Steve Jobs allure, and he directed the whole attention over there into the corner and said, over there you see two personal computers. And everybody said, yeah, and? Let's go there. We went there. And you know what we did there? We did the first PC to PC transfer of money with a little thing called telecounter. That's, by the way, still visible in some dark places on the internet. There were electronic transfers at banks, but not from personal computer to personal computer. You know what the reaction of the top brass at UBS was? Money is trust. No one will do online banking. Two questions. First, who of the audience was in the last 30 days in a bank branch? Okay, that's minority. I don't know what you do. We must be really dinosaurs. The only people who do that have no or gray hair. Okay, good. All right, totally discrimination. Now, second question. Who of you in the last 30 days, actually I only can ask 4 people, did go to a bank branch to either deposit money or retrieve money? So we went, you did?
My daughter had like the coins and
the coins in the machine. That's fair, that's fair, that's fair. So we have established who the true dinosaur in this room is. Now, why do I tell you that story? I might not be around in 30 years, I'm 54, I might be dead. As John Maynard Keynes said, in the long run we're all dead. But some of you are going to be around in 30 years. It will be a completely different world. It will be a completely different world. And I say that as someone who has been in the digital space for a long time and who doesn't buy into some of the nonsense like blockchain or metaverse. Come to me at the apero, I'm going to explain why it's nonsense. But this thing here is really game-changing. So let's start first with the obvious. Who is who? I saw the picture with Victor. Who created these pictures? Any one of you knows that? Obviously, some large language model. Now the question is, who is who? Anyone, any ideas? To the left, MS Copilot. To the right, OpenAI. Same prompt. Subtly different picture, but conceptually the same thing. This is one of the fallacies, my friends. A large language model is not intelligent. It looks like, but it's not. You see it here. It simply computed something very similar based on what it has seen before and what it was trained. That's it. That's it. We are far away from general artificial intelligence. But the interest, especially in agents, is high, right? This is a bit of a hype. I actually went to Google AI search terms last 5 years. Right? This looks like the Bitcoin increase, right? It's interesting, apparently. And we just heard what the definition is. So instead of doing fine slides like Victor did, I brought that to you as a text-based piece. But you know already now what agents do. So let's look what really happens. And obviously, I'm going to do the shameless sales plug here, but for a reason. We heard before about retrieval augmented generation. And the folks of you who start to apply large language models in enterprise context have heard that concept truly many, many times. Now, why do you use a search engine, the retrieval piece, with a large language model? For 3 reasons. Number one, it's actually pretty expensive, DeepSeek aside, and by the way, DeepSeek is not cheap either. They have been bending the truth subtly on how expensive that is. It's expensive to uptrain a local model. And it's going to be expensive for some time to come. Number two, a large language model is probabilistic compute. That has an implication. It's often wrong. And if you understand how these general pre-trained transformer models work, you'll understand it can throw as much money against the wall as you want. It's always going to be a bit of hallucination elements to it. Always. And number 3, especially in enterprise context, a large language model has no notion who is allowed to see what. Now, I know Ginetta does this holacracy thing, but this is one of a kind, right? Most companies have strict delimitations who is allowed to see what. An LLM, you have access to the LLM, but within the LLM, everybody sees everything. That's the core purpose of the whole thing, right? Now, I know there are some papers around that you can do that, whatever, but frankly speaking, no. So with respect to this, you invent this retrieval augmented generation piece to augment such an LLM with internal data. You, as an example, in the retrieval stack, do things like access control and all the rest. But now here's the point. Retrieval, by definition, is probabilistic. Probability plus probability has never given you certainty, at least in my universe of mathematics, right? Now, if you know that you can reduce hallucinations, but you're still widely off basing enterprise decision-making on such a system. Wildly off, right? So what do you need to do? You saw it on the slides before. You need to do knowledge graphs. Why? You need to reference your decision-making in certainty. Knowledge graphs can do that to a large extent. What you then need to do, you need to, especially in regulated industries, add guardrails to it, right? Go to any financial services company and ask them, is a financial client advisor freely able to, as an example, give you financial services advice? No, they're not. Not because the bank doesn't want that, but because the regulator says no. MiFID 3, anyone? Here we go. What you then need to do, you obviously need to do things about data security, right? You cannot expose sensitive data to a public LLM, obviously. And then you need to do things like operational data. Most of the companies still run on numbers, not on text. Now it's called large language model, not large numbers model, right? So you need to twist the whole thing a bit. Now, if you do all of that, you can start to automate actions like we heard in the brilliant presentation before. That's the agent piece, right? How does that work? In our case, it's exactly like you described. Water is about the same everywhere, so even though everybody says agent, 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 at the end of the day, it's about the same thing. Like Victor said, you have a question, you go to an agent framework that out of a toolbox starts to select what could be the potential selection or combination of tools, right? In an enterprise setup, you need to do all types of things about, which tool to which database of which action because of permissioning. We skip all of that at the moment. And then you go to the underlying data, you kind of like assemble that like Victor explained. Sounds easy, in detail is not easy, right? Especially because of the following. At the moment, I have a good laugh if people talk about agents, right? Because frankly speaking, 90% of all agent talks is simply agent used as a new name for a good old workflow tool, right? And our industry, the IT industry, is phenomenal to put new lipstick on the exact same pig and chase that exact same pig down the road again, right? And agents is the latest hype on that. Why do I say that? Why do I say that? Most of enterprise applications, most of enterprises, that's the way I should say it, most of enterprises are a combination of IT boxes that don't talk to each other. Where the CRM system has a very different way of how data is set up versus, as an example, an ERP system, right? And who has ever gone through the nightmare of doing back-end or front-end RPA integrations knows about this stuff, right? Now, in the moment you want to deploy an agent framework in such a setup, you need to do one thing. You need to deal with enterprise ambiguity, right? And that's the big breakthrough. That's why I was before saying the world's going to be in 30 years a very different one than today. Because the combination of these large language models, which can deal with ambiguity, language is ambiguous, plus a couple of these elements what I showed you on the previous page, can deal with that enterprise landscape. That's the game changer. That's the game changer. And I'm not just talking about that, I want to show that to you. I want to show that to you in a little video, if you agree. I hope that works. Let's see. Now, let's go. So, we start. Alan Leclerc wants to start as a senior solution engineer with our company. Alan, you don't know that yet, but you're going to come next week, right? No? Come on. And then you see what I do, right? The system prompts me something and asks me, actually, you want to submit an incident ticket, right? And I actually on purpose start to derail the whole thing, right? I on purpose say, no, this is about the presentation tonight on Digital Shift. I don't have my notebook. All what I tell you, actually, I generated with our own setup, with our own tooling, right? Every single slide I generated with our own tooling based on our own data. And then it gets it, you need a presentation. And then I say, no, sorry, I tried to trick you. You see that at the very bottom. You're going to see it in a moment on the back end. No problem at all. Let's get back to the self-subscription. It understands it. Why does it do that? Because we went in the back to the graph, to the knowledge graph, where we have the business process in, right? Where the knowledge graph gave it an indication what to do, and then it went back to the agent framework, and now it essentially asks what I want to do, and now I say yes. It comes back with the answer, and I did not create, Alain, for you now the self-subscription. Happy you. But I created the ticket, right? I created the ticket in a third-party system. Now you say to me, that's not rocket science. Yes, it's not. But it's about like 30 years ago when you had that PC to PC initial screen from a little green, there was not even Windows around at the time, from a little green lit screen where you started to wire money from one to the other of these personal computers, right? That's about where we stand with that whole thing. That's about where we stand. But if I go now back to the presentation, what happens now if you start to deploy this? And I just took one case of a company that we at the moment have the privilege to work with. And without going through all the details, I already speak too long, you see effectively sort of a business process. In this case, it's sort of a support process, right? All of us who have ever called a support service desk, we know how that goes. It goes endless and endless and endless, right? Now, obviously, this is the unbiased sales pitch. You can reduce that to nothing. Now you say to me, yeah, that's sales. No, it's not. We did that at this company here. You see it in the top left, who it is, for their IoT business. So this company operates telecom infrastructures. Some of you have taken here the elevator. there is this little emergency button, and the moment the elevator doesn't work, you effectively call up a call center that sends someone to get you out of that elevator. That is not normally an infrastructure that's done by the elevator company, but here in Switzerland, often by Swisscom, Europe-wide, often by Vodafone, right? This can go wrong. A router can go kaput. Then you need to replace it, because otherwise you're not allowed to operate the elevator. So you have high SLAs that you need to meet, because especially in high rises, say in London, it's a bit uncomfortable to go by stairs, 100 stairs, 100 floors, right? So what we've done with them last summer is we employed exactly what I've shown you here before on our own data. I cannot show it to the live data. And I want to show you what now happens in terms of business case, right? And it literally blew my socks off. I have not seen unit economics as big for the last 25 years. And the last time I have seen such unit economics, when you, Jörg, and us at the time did Otto Fischer web shop, right? That was as transformational 25 years, so maybe now even longer, 27, 28 years ago. Today, Vodafone takes about 9 steps just to qualify the ticket. What happened? Which elevator is it? What router is it? And that takes them anywhere between 15 minutes and an hour a step. On average, 6 to 7 hours, during which that elevator won't work, because it's not permitted to operate an elevator without the emergency button. Right? And we reduced that to 3 steps. In a clever combination of what you just saw, a chat that's been given to the elevator operator, but also using effectively the fact that this is not the first router that went kaput, but hundreds of these routers went kaput before, and we simply do what large language models can do so well, similarity. Have you seen actually already another such elevator going kaput? It's about these propensities, right? So we essentially use that fact. Phase 2, we have started to do agentic resolution, because in the moment you know what went wrong, the guys operate about 7 logistics hubs around Europe, where today you effectively store these routers and other elements. Hey ho, you can effectively go, take such an agent, go and see in which warehouses is it, and we shrink wrap that process as well, right? You reduce hours. Now you can go to any jurisdiction on planet Earth, whether it's high-priced jurisdictions like London or Zurich, or whether it's low-priced jurisdiction like the Philippines or so, right? The delta is so massive, it's literally irresistible. And the real eye-opener for me was when Eric, that's the head of that division, came around to me, and we presented that to him and said, look, my guys will present that case to me as a cost-cut case, which it is. We're going to save lots of money, right? But you know what it really is? For me, it's actually a revenue generation case. Why? I didn't get it initially. He said to me, look, at the moment, I'm out in the market with SLAs for the first response of about 7 hours, because I know that's the time I need to get this thing sorted. You know what I'm going to do? I'm going to go now in the market with 3 hours. Oh, by the way, you will still have a gift to me, because I can do that trick twice over the next years, from 3 to 2, from 2 to 1. Right? I'm going to be massively better than my entire competition. Right? And this little element last year, we did that mid last year, opened for me the eyes, right? It is, from an economic perspective, so irresistible. For as long as we play capitalism, we can discuss at the uproar whether that's a good way to organize societies, right? But for as long as we do that, any CEO will do that, because they either have a more efficient operation at reduced cost or generate more money and profit. And that's all about capitalism, right? And that's the equivalent what I wanted to tell about what we saw 30 years ago when the internet came. It had that same economic principle. And this is not just reduced to services. I on purpose started to put here on this little map where else this agentic bomb will hit. Now, at one stage, and you saw in the background sort of a port value chain diagram, I simply ran out of space. This is literally the biggest disintermediation and reintermediation opportunity of a lifetime. Because you can literally rethink every single business process over time. Now, that's not going to be today, it's not going to be tomorrow, it's not going to be the day after tomorrow, but over the next 10 years, you're going to see literally a rethink of every single business process because of the economics of what I just described. Now, you might ask, yeah, what happens here? This is a bit of a hypothesis that we're going to go into this economic network setup, but we're already talking too long, so here's a little takeaway, right? If you ask yourself now what to do, I would not want to start immediately with the full shebang. It's tough, right? But what about you simply start small, chatify. Then you might want to scale up and do maybe recommendations. And at the end, and that's the piece, you can effectively think about entirely novel ways of delivering services, right? And I always say that. Who of you in the room does know CityDisk? There's a clear differentiation between old-aged people and younger-aged people, right? So the old-aged people in this room went to buy their CDs in a store called CityDisk, while you guys all have Shopify subscriptions. What? Yes, CDs. Yeah, what the hell is that? It's exactly that same moment we are here. Now, my personal view about that, I have spoken a bit about that during the presentation. It's not about machines going to replace everything. That's not what's going to happen. One needs to rethink who does what. Because while everybody is going crazy about the agents, I spoke before about the fact that these things are not infallible. Right? So you want to have a human-machine interaction. The way to think, we can talk at the upper about that, in my mind, is an ATC controller. Come and talk to me about that. Now, let's go and get things done. What always helped me over the past years is Larry Ellison, good old Larry, right? Who said, if you innovate, everybody thinks you're completely nuts. But if you don't try, you don't win. So, thank you.
Thank you very much. I think you can stay here for the panel. You're very welcome to place your questions now. Okay.
I've got a question about Vodafone. Who are the people who decide to use now those agents? Who are the departments who say now we work more with agents instead of normal service people?
I cannot answer that specifically only for Vodafone. I have at the moment privilege with my company to be active in Singapore and New York and the rest of the United States. So we see a lot of that stuff happening. Here's how I look at it, right? Before 22, AI was minority sports. In 23, ChatGPT came, everyone said, oh, yeah, what's happening here? 24 was pilot galore. Every self-respecting CIO went to their CEO, got massive budget to have a new toy in-house. I hope there are no CIOs in here because I lost them now, right? And now 25 will be about how to get from pilot to production. And that's a whole different ballgame, especially in enterprises, because you need to go about scale, you need to go about what I just talked about, permission enabling, and. To come back now to your question, I think most companies at the moment underestimate the intellectual element to that whole quest. They go in a very happenstance way. Oh, it's so interesting, let's go and do things. They don't think about that holistically in a way that they say, here's a business process that if I apply that type of technology, I could do here better, right? Instead, they go a bit like hobbyists at that. I think that's about to change. I see in some cases very structured approaches of rethinking the way they deliver value to customers, to shareholders, stakeholders. And as a part of that, they start now to think about how can they, as an example, set these workflows up in a combination of software agents, so to speak, and human agents. But I think that's only to come.
What we saw here is that we reformulate how business is done, put it like this. At the same time, we saw that we create a massive dependency on foundation models, and dependency on infrastructure, and dependency on a lot of stuff we don't control. So how comfortable will the future be?
Any one of you guys operate the big SAP infrastructure? SAP is ransomware. Don't ask me. Go ask the SAP user group. Right? No, seriously. I'm not making jokes. Go and ask these guys. Frankly speaking, you're going to exchange ransomware SAP for ransomware OpenAI.
Yeah. So, no, but that's a good point. But I mean, there's so many options. But I'm going to give you because he's talking about dependency. You have different options. You have easy options. You have difficult options. You have to see. There's always a trade-off between how fast you want to be and how not coupled you want to be. If you want to be completely decoupled, you have a lot of very like a wide range of open source options that are actually not difficult to put in. Just it's going to be a bit more complicated. But you can, I mean, we have a lot of options, and we have a lot of very good open source options. But it depends what you want to do. If you want to do some stuff, you will be able to do, others, not so much. For example, in my case, because I'm working in regulation, so I'm obliged to use open source. I'm not allowed to use any cloud infrastructure. So everything I do has to run on-premise. And I'm actually able to do almost anything I want. The only thing is that when I build, so I start building with big models, like OpenAI, and then by adding more prompt engineering, by doing more software engineering to validate, and by breaking down the task into smaller tasks, at the end of the day, everything I was able to do with OpenAI, I can do it with an open source model like Mistral or DeepSeek. So.
I want to add another point that is mostly overlooked. You do that in RegTech, that actually triggered me. I'm getting easily triggered. So here's the thing, right? Who of you guys is a lawyer? All right, we know, Martin. You're smart, you're not going to fall into that trap. But a lot of lawyerly firms at the moment fall into that trap. They all run for Harvey, as an example. It's one of those bespoke solutions for the lawyer profession, right? Now, why do I say it's a trap to some extent? Any law firm works on a pyramidal principle. You go in as a junior, you become an associate, you become eventually, whatever it's called in their language, a manager, whatever, eventually you become a partner and charge obnoxious hourly rates, right? That's sort of the model in law firms. You agree with me? Now, what happens if you eradicate the junior levels, because the junior levels are handed over to AI? And you do that for more than 5 years. Who is going to go to the mid and higher levels if you actually have, on purpose, cut away your junior levels? You follow me? We will go fast into an area where, and that's actually the Achilles heel of the whole thing. For economic reason, it makes sense to go the Harvey route, but for longer term, structural, kind of like economic terms, it doesn't make sense to go all the way Harvey, right? Because you essentially miss the talent to replace you, right? And it's a largely overlooked element in that debate.
Let me add on something on that. AI is very popular and very good installed in large companies because they have very well organized workflows. But as soon, especially in Germany, for example, if you're on the middle-sized level on the way, sometimes, still today, I feel we put a plug into a cave, because when you place the agents, you have to be sure that your workflows are clear. But it starts there. In many cases, they are not clear. So we don't even know how to teach the agent what to do because the business case is not even clear. So AI does not solve you if you have a wrong business case. It shows you that you have a wrong business case. Yes, it helps you to find that out, and then you can sort it out. And the other point, which is also very important, you said it many times, you have to be able to work with your own data because you know the quality of your own data. You cannot trust the data which is harvested if you don't check it. But in many, many companies, these data are not available yet. Those are subsystems, they make and export the data, they are maybe structured, they are unstructured. And so before you even start implementing the AI, you maybe have a job to clean the house first. And that's what we face in many, many small and middle-sized companies. They have a lot of money, they made a lot of money, so they like to invest it into AI, but we find out, okay, first we have to clean the house, and then maybe in 6 months, we start talking about how to implement AI. And that's the reality if you're not talking to the very large companies which do have those, by law, have this workflow streamlined. Who is next?
Yeah, I'm Timo. That's the perfect moment for me to ask a question. Because first, what you said, Dorian, I'd like to challenge that perspective. I believe that the juniors in the law firm will probably be the people who benefit most and will be most able to use AI to up their own game. So maybe the kind of the first floor will just be raised. To what you said, that reminded me actually of the beginning of my reasoning and question, because I believe that it's not only the data that needs some housekeeping and the processes, but also the organizational structures that are now very much centralized in many organizations and very unflexible. And my question is, do you see patterns or anticipate patterns of how organizational development of the human interaction, how people work together, will be influenced in the next few years by that AI revolution?
Anyway, there is lots of research why organizations exist. And I believe one guy was called Wilkinson. I would need to dust up my PhD thesis. And effectively, I think his point was organizations exist because the cost of transaction is lower within the organizational boundaries than between organizational units of independent jurisdictions or setups, right? That was his main argument. And I believe he won even the Nobel Prize for that somewhere 60, 70 years ago. Now, if what I just described holds true, and I'm open to be challenged, right? I might be completely off and wrong. I also thought Trump wouldn't win a second term. I was also wrong. That said, okay, that's for the applause. But if that holds true what I said, right, that same equation will change fundamentally, right? And sort of the cost of transaction between different organizations will be reduced, and thus it will be way more attractive to deal that between organizations and to necessarily have that within one organization. And yes, indeed, that would be my bet. Once these agents get to adulthood in terms of quality, of consistency and all the rest, the economics I have seen in those couple of early cases point everywhere to that direction. The other point I want to make is, you talked about a junior being able to profit more of these AI tools. Who of you has kids in the school age, right? It's really tough to tell them to go and read. I hear a lot of agreement in the room, right? So what I want to say is, that's actually one of those dangers, right? Comprehension, our way to think, is trained by a continuous loop of us really going deep into certain subjects. If you only have youth watching TikTok in 10-second clips, it's a mashup here, but it's not anymore very structured. It took my wife and my daughter and myself a long time to get her hooked off again of that nonsense. Right? To really make sure that she invests, reads, tries to understand and comprehend, just doesn't only rely on whatever ChatGPT tells her. Right? And if you don't have that discipline, hey, yeah, juniors will profit from that. They can do twice as much work in as little time, but that is half of the points of them being only hired 5 when they were hired 10, right? And these 5, because they are too dependent on whatever ChatGPT says and not on their own brains, they're never getting promoted.
I can just add something about the juniors. It's actually not so good for juniors to have AI. I mean, I'm talking for software engineering. That's the domain I know. If you take junior software engineers, they're not per se better with an AI because the problem is you need to know how to ask the AI properly and you need to validate what the AI does. And in my experience, seniors are very good with using AI, juniors not so much. And actually sometimes it's even bad because they, when I say they have to use the AI properly, it means they have to use the AI properly and also understand what was done. Not just do the thing and then hope that everything's going to work and then a few weeks later it doesn't work and they don't know why it doesn't work. So, yeah. So, yeah.
This triggered me again. I need to go clean on my lost Trump bet. So here's the bet, Victor, that you and I are going to offer to the audience. It's actually a rejoin of what you just said. Right? So here are 2 juniors in a large bank. It's Friday afternoon, 5 o'clock. What do juniors do in a large bank Friday afternoon, 5 o'clock? Go out, get drunk, get laid. Thank you very much. Siri agrees. Okay, good. So the bank has 100% 4i principle to check in code. You agree, right? That's what they do, right? But it's 5 o'clock. The senior to the junior also wants to get out drunk and late, whatever, right? So what do? They say, it's okay, John. Let's go, right? And too bad. They overlook that statement with that, unfortunately, just slightly off, looking very correct variable statement, but it's just slightly off. You agree? Okay. It gets checked in. These dudes have a wonderful weekend. On Monday morning, they come into the bank again. What do? They go back and go and verify that variable statement from Friday, 5 o'clock? No, they talk about the one-night stand they had from Friday to Saturday, right? And then they move on. You know what happens 5 years later? The equivalent of a big fat finger event. That variable is slumbering along, and then suddenly there is this exception, and the variable should have been called in a different way. You know what? The whole training floor goes down. Here's my bet, my friends. Victor and I don't know, maybe you could join me or not. I offer you a massively big case of Bordeaux wine, and in the next 5 years, you're going to see a big institution going down the drain because of exactly what you just described. That is, somebody in a stupid way checking in codes that 5 years later essentially causes the whole thing to go down. Any takers come to the upgrade to me because I need to get good on my lost Trump bets.
And what's the difference to today? So what you said triggered me as well because.
Sorry. Because I think that's kind of the same concerns you might have had when assembly was replaced by 2nd generation and after that by 3rd generation programming languages. You need to understand on an assembly level what the computer does, otherwise it will just fuck you. So what's different now?
I think there's one sample which we all will understand very well. Take auto driving in cars. What a big mess we will face. I mean, just imagine if you're in a city, if you have IoT and good connection, everything, but now you go outside off-road and your car should make a maneuver automatically and he can't. and now you should drive. And you've never really driven because it's all automatic. You go on the motorway, everything is organized, your car is driving himself, and all of a sudden you're in a special situation and you have to drive yourself. It's an accidentally situation. That's a big challenge we will face because, I mean, in the States, everybody has automatic cars, so they can't even drive the gear change. So that's the first challenge. But just imagine the young people will have all this experience. The parking is automatically, they go on the motorway automatically. So you trust much more on the car than on the driver. And all of a sudden he is a little bit off-road and there is no connection and he would do them himself. Oh boy, I'm looking forward to see that. And that's with everything. That's with the education. You know, people, when we had the first calculators, everybody started using the calculator. Nobody could do it by manual, didn't understand how the basics of the calculation goes. Of course, you can't solve the bigger problems if the calculator is not pre-programmed to help you, if you have to go back and think yourself. And I think that's a big challenge in general on the AI. How do we deal with this situation that we have these assistants, the agents, and we may lose or forget how we did it manually? And I think that's a big challenge coming to us in the education, in training, in apprentice, everywhere. How do we deal with that?
We will have one last question from Rafi, and then we go for the apéro.
Okay, so who is placing the last question? Please.
Thank you very much. So I'm Raphael from Justi. So we are in the business of apprenticeship training. I wonder, the building blocks I see is the prompting and training people to really know about. And we face the challenge in our company, should we invest in the people, yes or no? Should we invest in tools, yes or no? What is first, chicken, egg? My kids actually love ChatGPT. And my older son has problems with reading, and since he is involved with ChatGPT, he can unleash his curiosity.
Yeah, so just what I would say is that, because you said that it's important to know how to use AI, I think that's the most important thing for the next generation. Because I read somewhere that they said that the future, you're going to divide people in two categories. The people that are complementary to AI and the people that are substitute to AI. And the substitute, they're going to be in a very bad position. So we need to, and that's what you, example, your kids. So definitely the kids has to be complementary, but to be complementary, you need to learn how to use AI properly. And for the software, the junior, that's exactly what I meant. The software engineers, the junior ones, it's not just you give him the tools, you have to teach them how to use the tool. And it's actually much more complicated than people think to really know how to use AI properly and not just play with it. And so that's my. Yeah.
Thank you very much, Dorian, Victor. And for the questions, I think we close at this point. You're both here, so if there are more discussions and questions, please use the networking with the nice aperitif.